Hi class, it's Mrs. Kane and I'm here with your next e-learning video. We're going to move on from compound interest, and today we're going to start talking about solving exponential equations. So what you're going to notice about the equations that we take a look at today is that the variable is in the exponent. Okay, so if we take a look at example 1, we're asked to solve for x, and it says 5 to the 3 minus 2x equals 5 to the negative x. Okay, so what you should notice is that the base of each exponential expression is the same. So if these two expressions are equal to each other and they already have the same base, then that means their exponents also have to be the same. So all we have to do here is set our exponents, 3 minus 2x, equal to negative x. Okay, and then we need to solve for x. So we're going to go ahead, I'm going to add 2x to both sides. And we get 3 equals negative 1 plus 2 is 1x, and so x equals 3. Okay, so when those bases are the same, it's a pretty simple problem. Just set the exponents equal to each other and solve for x. So the next problem is similar. We have 4 to the 2x equals 4 to the negative 2x minus 1. So because they're equal and they have the same base, we just need to set 2x equal to negative 2x minus 1. Okay, so I'm going to add 2x to both sides to get my x's together. I get 4x equals negative 1, and then I'm going to divide both sides by 4, and we get x equals negative 1/4. Okay, so the most basic type of exponential solving problem is when the bases are already the same. So the next set of problems we're going to look at is, what do we do if the bases are not the same? Okay, so if the bases are not the same, we are going to try to use properties of exponents so that the bases are the same. Okay, so in the next set of examples, we're going to try to rewrite either one or both sides of the equation so that they have the same base, so that the exponents have the same base, and then we can proceed like we did in example 1. All right, so the next example, we have 5 to the 2x plus 7 equals 25. So you want to try to rewrite the larger number, in this case 25, using the same base as the other side. So what that means in this problem is we're going to try to rewrite the 25 so that it has a base of 5. Okay, so we know that 5 squared is 25, so we're going to replace the 25 with 5 squared. And now it's just like example 1. We have two exponential expressions that have the same base set equal to each other. So therefore, the exponents, 2x plus 7, must equal 2. Okay, and then from there it becomes just a linear equation. We're going to subtract 7 from both sides. 2x equals negative 5. Divide by 2, and x equals negative 5 halves. Oops. Trying to move that up a little bit. There we go. All right. So the next problem, we have 2 to the 3x minus 2 equals 32. So again, try to rewrite the larger number, the 32, with a base of, in this case, 2. Okay, so some of you right away recognize, oh, 32 is 2 to the 5th power. Okay, if that wasn't obvious to you, you could use guess and check in your calculator. If you do 2 to the 3rd, you get 8. 2 to the 4th, 16. 2 to the 5th, bingo, you get 32. Okay, so as soon as we rewrite that 32 as 2 to the 5th, now we have the same base, and we're just going to set our exponents, 3x minus 2 equal to 5. I'm going to add 2 to both sides, and we get 3x equals 7, divide by 3, and x equals 7/3. Okay. All right, now we're going to review some properties of exponents. So in the next example, we have 3 to the 1 minus 2x equals 1/9. Okay, so in this case, we're not going to try to write 3 with a base of 1/9. So instead, we're going to try to write 1/9 with a base of 3. So 3 to what power equals 1/9? That's what I want you to think. Okay, so we know 3 squared is 9. Okay, so we can put a 2 here, but we don't want 9, we want 1/9. So what must have been done to that 2 to turn this into a fraction? Okay, so notice if we make that a negative 2, we drop it like it's hot. 3 to the negative 2 equals 1 over 3 to the positive 2, which is 1/9. Okay, so for this one, we're going to replace 1/9 with 3 to the negative 2 power. Okay, so now we can set 1 minus 2x equal to negative 2. All right, and then in this case, I'm going to go ahead and subtract 1 from both sides because my x is already kind of isolated on the left there. I get negative 2x equals negative 3. Divide both sides by negative 2. A negative divided by a negative is a positive, so we get x equals 3/2. Okay? All right, the next one, we're going to use another property of exponents. We have 4 to the 2x plus 3 equals 1. Okay, so in this case, it doesn't make sense to rewrite 4 with a base of 1 because 1 to any power is going to be 1. So instead, we're going to try and replace the 1, okay, with a base of 4. So 4 to what power equals 1? Okay, and hopefully some of you are recognizing that zero exponent property here. Any base to the 0 power equals 1. Okay, so we're going to replace the 1 here with 4 to the 0. Okay, and this is something you're going to start to recognize. Anytime you have one side is exponential, the other side is 1, you can just replace the 1 with the same base to the 0 power. So to finish this problem, we have 2x plus 3 equals 0. Subtract 3, 2x is negative 3. Divide by 2, and x equals negative 3/2. Okay, so hopefully those problems make sense. Your goal is to rewrite both sides with the same base so that you can set the exponents equal to each other and solve. All right, and then the last type of problem I'm going to talk about, we're going to use the product property of exponents. Okay, so the product property says if you multiply two expressions, exponential expressions that have the same base, you keep the base the same and you add the exponents. Okay, so for example, 2 to the 3rd times 2 to the 4th, we learned is 2 to the 7th. Okay, so we're going to be applying that property in the next set of problems. So we're asked to solve for x. We have 4 to the 2x times 4 to the x equals 64. So before we try to rewrite this, we're going to combine the left side so that we just have a single exponential expression. So I'm going to write this as 4 to the 2x plus x equals 64. Okay, and 2x plus x is 3x. So I'm actually going to replace this with 3x. Okay, so now I'm going to try to rewrite 64 with a base of 4. So again, you can use a calculator. We know 4 squared is 16. If you type 4 to the 3rd, you get 64. Okay, and so what we're going to do next, we're going to write 4 to the 3x equals 4 to the 3rd. So our goal is always to get the bases to be the same. So now we have 3x equals 3. And x equals 1. Okay, let's do one more together. So in the next example, we're going to start, you got to start by combining the left side into one exponential expression. So keep the base 10 the same, and then we're going to add x plus 4 plus x plus 1. We're not multiplying, we're adding. Okay, and then that's going to equal 1/10. So we have 10 to the x plus x is 2x, and then 4 plus 1 is 5, so 2x plus 5. And then we have to figure out how can we write 1/10 with a base of 10. Okay, so what I want you to do, we know 10 to what power is 1/10. So we know 10 to the 1st is 10, so what made that go to the bottom? Okay, anytime you're trying to rewrite the base and make it a fraction, you know that exponent's going to be negative. So 10 to the negative 1 equals 1/10. So we're going to rewrite the 1/10 as 10 to the negative 1. So now we have the same base, so we're going to set 2x plus 5 equal to negative 1. Okay, and then we subtract 5 from both sides. 2x equals negative 6. Divide both sides by 2, and x equals -3. Okay? So a little practice with those negative exponents. All right, I would like for you to pause the video at this point and then go ahead and try the next 3 problems and check your answers. Okay, if you still need a little further explanation, go ahead and watch along as I solve these. Okay, so the first one, we're going to rewrite the 1/8 as 2 to the -3rd power. Okay, 2 to the 3rd is 8, so if our exponent is negative, that will make it a 1/8. So now I'm just going to set 2x minus 3 equal to -3. I'm going to add 3 to both sides. I get 2x equals 0. Divide by 2. 0 divided by 2 is 0. So the first answer is x equals 0. Okay, the next one. Remember, anytime you have an exponential expression equal to 1, I can replace 1 with 7 to the 0. Okay, so I'm just going to match the other base on the other side. So 4x plus 8 is 0. Subtract 8. Divide by 4. X is -2. Should have written that, sorry. Okay, and then lastly, I got to combine these using addition. So 4 to the x plus 4 plus x minus 6 equals, now I'm going to rewrite 16 as 4 squared. Okay, so now I have x plus x is 2x, 4 minus 6 is -2, equals 2. Add 2 to both sides, 2x equals 4, and x equals 2. All right, so hopefully that makes a little bit of sense. You can rewatch any parts of it if you need to revisit it for more explanation. We'll continue talking about solving in tomorrow's lesson. Thanks a lot. Have a great day.